This is a tutorial on differentiation using the chain rule. Before I get into the examples, I just want to lay out that the first example is going to be this function here, where it's a power to the 4, 3x squared minus 8. And then the second example is a cubed root with a fifth order polynomial inside it. So just to state that if you want to start on this example, I'll be doing that first, but if this is a particular kind that you're looking for, then you can skip to this example halfway through the video. So they're the two examples we'll be doing today. Alright, so beginning this equation, we're first going to read the note that I have on the top right hand side. The chain rule is a type of differentiation. It's a method used on composite functions. Now a composite function is a function that has both an inner and an outer function. So reading that and then applying it to our first example, we can see that we indeed do have a composite function. So our function is 3x squared minus 8 to the 4. So our first inner function is going to be the 3x squared minus 8, and our outer function is going to be the raised to the power 4. So this whole function to the power 4. So that's our inner function, and then we have our power to the 4. That's going to be our outer function. The second thing to note before diving into it is the rule here that I'm sure everyone is familiar with. We're going to be using it a lot throughout both examples, whereby you have a function y with respect to x, so x to the n, and then if we want to differentiate that, we're going to dy dx, that's equal to the power that's brought down in front of the x, or the function, as a coefficient, and then the function raised to that n power minus 1. So y equals x to the n. The differentiated version of that y is nx n to the minus 1. So again, just to keep that in mind as we work through these examples. Okay, so diving straight into this one. So as I mentioned before, this is a composite function. So we have an inner and an outer function. So the inner function we're going to label here to be v, and then we're going to label, say, the outer function, which is just the power raised to the 4, as u. So we're just going to label the inner function v and the outer function u. So knowing this, you can now rewrite this f of x function. So you can rewrite the f of x to be equal, we know the outer function is u, and then the inner function is v, it depends on x. So u, and then the inner function is v, and we know it depends on x. So the fx can be written in this way. It's basically just a summary of the original fx that we have up here. Now I'm going to write down here the equation that we're going to use to differentiate. It's the chain rule equation, and it's given by f prime x. As you know, the prime is signifying that this function is differentiated, and the equation we're going to use is we're going to differentiate u with respect to v. So that's what that means. We're differentiating u with respect to v, and that's in product with differentiating v with respect to x. So all you're seeing here is the equation that we're going to apply to this function, and it's going to give us the differentiated value of that original function. So this is just the layout of the equation that we're going to use. Alright, so how are we going to apply this chain rule differentiation method to this original equation? We have labeled here a du dv. Okay, so we're going to differentiate u with respect to v, and then we're going to differentiate v with respect to x. Now, at first glance, it might seem a little bit overwhelming, but if we just lay out each component, when you actually come to apply this, it's not too bad. So first what we're going to do is we're going to lay out clearly what our components, what we have. So we labeled above that our v is the inner function. So that's going to be 3x squared minus 8. Inner function, that's it done. Alright, well, if v is that inner function, u, if you remember, is going to be the outer function. So what the u is going to be, it's going to be the v to the power of 4. Now, if you just take a second to make sure you get that right in your head. So u is the outer function, the power of 4, and v is the inner function. So if v is this inner function here, then u is going to be the outer function, which consists of this inner function raised to the 4. So our v is 3x squared minus 8, and our u is v to the 4. So inner function, so right here, so let's say inner function, outer function. Right, okay, so we have a v and a u. What we need to do now is we need to apply this method onto the function. So we can see that du dv is just going to be our u function, our u expression, differentiated with respect to v. So let's take this component and find it separately first. So du over dv, that's going to equal this differentiated. Now, this form here, if you can see, it mirrors that of what I had written up here explicitly. It's a function, in this case it's v, raised to a power n, in this case 4, and that equation differentiated is just going to be the power as the coefficient multiplied by the function raised to the power minus 1. Alright, so our power is 4, which is the n up here. So we're going to bring the 4 down in front, and then our function here is v, and then that's raised to the 4, but we know when we differentiate it, we reduce that power by 1. So then 4 minus 1 is 3. Alright, so if you look here, we already have half of this chain rule figured out already. The du dv we just figured out to be 4v cubed. So now what we have to do is we just have to figure out the other half of the chain rule, which is the dv dx, which we're going to be dealing with this v equation here. So now we're going to differentiate v with respect to x. As you can see that our v is dependent on x. So how do we differentiate 3x squared minus 8? Well, once again, we see that the 3x squared takes the form as we used just before in for the u expression, that we can now bring down the 2 as a coefficient, and it multiplies itself by what's in front of the x already. So if you want to do it explicitly, you could write the 2 comes down in front, and then we have the 3 is already there, and then the function is x, and then we're reducing the power by 1, so it's 2 minus 1, that's going to be 1, which is just x as well. So then just going one step further, that's going to be 6x. So dv dx, where v is 3x squared minus 8, it's going to be 6x. Because as we also know, if you have a constant, if you're differentiating a constant with respect to a variable such as x, that's going to go to 0. So we only have to deal with the expressions in the equation that actually have the variable included. Alright, so we now have figured out the dv dx, and we've also figured out the du dv. But there's just there's about maybe 2 steps left to go. The first one would be, alright, so we've found du dv to be 4v cubed. But as you can see in our original equation, we're not dealing with v's. V was just a convenient stand-in that we used as the inner function. And we know the value of v, as we've seen it here, and we denoted it up here. So we now have to put that original v equation back in for v. So all that means is this is just going to turn into a 4, and then instead of having a v, which remember we just put as a stand-in variable, it denotes the 3x squared minus 8. So we now have to put the v expression back in, i.e. the 3x squared minus 8. And then we know that's raised to the 3. So the full value of du dv is 4v cubed, and when v is inserted back in, we have a 4 by 3x squared minus 8 to the power 3. And you see we don't need to do anything like that here because v was always dependent on x, so there's nothing to place back into the dv dx. Alright, so again, looking at the chain rule, we have du dv, we found it, and we have dv dx, we found it. So we then know that f prime of x, the final result, du dv, is here. So let's pick this up and put it in. 3x squared minus 8 to the 3. and we see that's in product with dv dx, which we found to be 6x. So then just tidying that a little bit more, we can bring the 6x to the front. So our final differentiated result is 24x multiplied by 3x squared minus 8 to the 3. So this here is our final result. Okay, so this is the second example of this video. If you've skipped here, I'll be going through the initial steps again. And if you have looked at the first example, it's always good to get more exposure to it. So yeah, the first point to note is it's a composite function, so we're going to be using the chain rule as I've defined over there in the top right hand corner. We have an inner function and we have an outer function. So the first thing again is we're going to actually denote the inner and outer functions, as it just makes the whole thing easier when we come to actually apply the chain rule. So I'm going to write the chain rule first. So it's f prime x, where f of x is this function, and it's going to equal du dv, which we're going to define in a minute, and that's going to be multiplied by dv dx. Okay, so the first thing to do, as I just mentioned before, is we're going to write down the inner and outer function. So the inner function is going to be v, and that's going to equal this fifth order polynomial within the cubed root. It's going to be the 5 minus 6x squared plus 2x to the 5. So this bit here is our v. And then our u is going to be, don't have much room here. Our u is going to be the outside function, which is the cubed root. So we write that down. So if you remember, we just have v inside the cubed root. So now u is going to be dependent on v. As you can see, v is inside u. So u is going to be v. And then what's another way to write a cubed root? It's going to be v to the third. So that's just another way to write a cubed root. Similar, if it's just a square root, it's the same as the inside function to the power of a half. It's just that we have a cubed root, so it's 1 over 3 as opposed to 1 over 2. All right, so now we have our v's and u's. So now we're ready to apply the chain rule. And then at the end, once we find these individual differentiations, we'll put it all together and we'll get the final result. So we'll start just down here. All right, so let's find our du dv, because that's the first one there. So du dv. Okay, so applying this rule to the function that we have, how are we going to do that? Well, we're going to bring the 1/3 down in front as the coefficient. So we have 1 over 3. And then that's going to be in product with the v. And now we have to, as the n minus 1 over here indicates, we have to reduce the 1 over 3 by 1. So 1 over 3 minus 1 will give you can just use your calculator, it'll give you minus 2 over 3. So that's our du dv value. We're going to have to insert our v in at the very end, but for now, this is okay. So du dv, which is the first part of the chain rule, we've now worked out. So the second part then is the dv dx. Now this is the inner function differentiated with respect to x. So 5 minus 6x squared plus 2x to the 5. So you can see that we're going to be using this rule that I've written up here twice in this function. As we know, constants when differentiated go to 0. So we just need to worry about these two expressions within v here. So a minus 6x to the 2, we're going to bring the 2 down as a coefficient. It's going to be multiplied with that minus 6. So 2 by minus 6 is minus 12. And then the power of the x will reduce by 1, which will give us x to the 1, which is just x. Then we have this addition here, where we bring down the 5 and it's in product with the 2, so that's going to be 10, and we're going to reduce this fifth power by 1, which will give us 4. So our dv dx is minus 12x plus 10x to the 4. Alright, so we found our du dv and we found our dv dx. So that consists of, or that makes up the whole chain rule here. We just have one step before we fill in the final answer, and that is we can see that we want this in respect to x and not v's and u's. So what we need to do, as we see that the du dv still has still dependent on v, we now need to take the v equation and we need to put it back into the du dv equation here. So that's going to change it to be in respect to x as opposed to in respect to v and the inner and outer functions, the VUs that we did. All right, so we're going to take the 1 over 3 v to the minus 2 over 3 and insert this v equation in here. So that's going to be v. So we'll just keep the 1 over 3. So I'll just go up here. So we have the 1 over 3, and v is 5 minus 6x squared plus 2x to the 5. And we can see that the v here is to the power of minus 2 over 3. So if you just realize that this here is equal to this, we've just inserted the v expression in here. All right, so now we have our true, let's say, du dv equation right here. So what we're going to do is we're going to rewrite this second one, as it's a little bit messy here. So just rewriting that will give us 1 over, that's going to give us a 3 here, the denominator, and then a minus 2 over 3. So this is going to be, when you bring this under the division sign, this will turn to a positive 2 over 3. So all we need to do now is multiply this 3 by the polynomial 5 minus 6x squared plus 2x to the 5. And now that it's in the denominator, this minus 2 over 3 changes to just 2 over 3. Alright, so this cleaned up is 1 over this expression here. Alright, so what we can do now is actually form the final result of using the chain rule on this cubed root function. So our f of x, f prime of x, so the differentiated result is going to be the du dv, which we found to be this value here. So it's going to be 1 over 3, 5 minus 6x squared plus 2x to the 5, and then that is 2 over 3. And now we can see that's in product with dv dx. So that's going to be in product with dv dx, which we found to be minus 12x plus 10x to the power of 4. Alright, so just made a little bit of room over here. So our final result is this, but we can just multiply this section of the equation over here just to have it as a single fraction. So doing that, we're going to have our f prime of x is going to equal minus 12x plus 10x to the 4, and that's all divided by this expression here, which is 5 minus 6x squared plus 2x to the 5 over 2 thirds here. You can tidy that up once more. This would be sufficient as a final answer, but if you wanted, you could see that there's this common value in here. There's a 2x, which is a common value. So we can take that out. So we can take 2x out, and then that's going to leave us with a minus 6. That's going to leave us with a plus 5x to the 3, all divided by 5 minus 6x squared plus 2x to the 5 to the power of 2 over 3. So that is a final answer. So yeah, hope you enjoyed. Like and subscribe would be great, and we'll see you in the next video. Thanks.